switch X and Y, I should say and, I don't like writing less. You switch your X and Y coordinates. That's what an inverse function is. You just switch your X and Y. The symbol for it looks like this. It looks like you're saying f to the -1. That's not what it means, though. It does not mean a power. It means the inverse of my function. The inverse of my function. So that's the symbol. So the first part we're going to do right now is we are actually going to graph a function. And we're going to graph its inverse. And its inverse. Okay. Graph f of x equals x plus 3 squared minus 5. And we're going to graph its inverse. And we're going to do it one way to begin with. And then I'll put it the other way. There we go. Okay, so based on the directions I just told you, well, first of all, you should all know what this looks like. This is a parabola, and it has been shifted where?
Left 3, down 5.
So left 3, 1, 2, 3, down 5, 1, 2, 3, 4, 5 means that is the point where its vertex is. Would you agree? Okay. You could put this in your calculator. I mean, that's fine with me, but the reason why I'm looking at that point, so I know that -3, -5 is the vertex. And so what I like to do when I graph parabolas is I like to at least find one on either side of that vertex. So I'll find one over here and one over here. So I'll pick another number that comes before -3, so -4, and then I'll pick one after -2. And you can just plug it in, or again, you can look at your table of values from your calculator. But if you plug -2 in, I think it's -4. No, it is -4. I mean, and these should actually mirror each other because it's a parabola, just FYI. You should know that. So -2, -4, and -4, -4. And then I'm just going to pick another one. Let's see, -1 and -5. So let's see what that would be. -1. So -1, -1, -5, -1. And you can draw your graph, your parabola. I'm trying to be accurate. There's a reason why in a minute. I'll show you. Okay. So now we want to draw the inverse of it. So what we do is we can just flip the x and y's. Okay. So to do the inverse portion, you just take, instead of writing -5, -1, you write -1, -5, and you graph that point. -4, -4, well, its inverse would still be -4, -4. -3, -5, you're going to graph -5, -3, and so on. Okay, and we're going to see what happens when we plot these points. So go ahead, plot your points. I will plot my points. So -1. That is the inverse function. Now, the inverse is special because not only, is it the x and y flipped, but what it actually does is if you were to graph the y equals x line, if you don't remember what the y equals x line is, it starts at 0, 0, and it goes up 1 over 1, up 1 over 1, up 1 over 1. It's this line right here. That's the y equals x line. And I know this might be hard to see, hopefully it won't be, but if you take this piece of paper and you fold it right over the y equals x line, can you kind of see through? I don't know if you can see through, but my green equation has actually landed on the purple equation. So when I grade you for inverses, I actually kind of just in my brain draw an imaginary y equals x line, and I know how you did it if you did it correctly. But on the quiz tomorrow, you'll have to do this, and you'll have to do it with accuracy with points. You can make a table of values. I mean, that's the easy way to do it. So how was that? Not hard, right? Okay, well, let's actually find this equation though, because how do you actually find the inverse equation? Because some of them you can, and some of them are difficult to find. So we're going to do that for our second part here. Okay, it's very easy. It's just similar to what you just were doing before. You switch the x and the y, and then you solve for y. So switch x and y, solve for y. Switch x and y. F of x is your, remember that is your y. So we're going to call this x. This one I'm going to call y. I'm going to keep everything else the same. And now I'm going to just start solving this for y. Let's talk this through together. What should I do first?
Add 5.
You add 5. Do not FOIL. I know like in everything else we seem to be foiling. Don't do that here. How do you undo a squared? Square root. When you take a square root, please remember you have a plus or a minus in front of what you took a square root of, and then y plus 3. And then very simply, you minus a 3 over, and I like to put the number in front of the plus and minus, so it'd be minus 3 plus or minus the square root of x plus 5, which is y, which is actually the inverse function. That is the inverse function of a parabola. A parabola actually is comprised of those two square roots. This is what this is, a square root. So let's see if it's still in my, nope, it's not. Just to give you a picture here. Let me graph the original. X plus 3 squared minus 5. And then for this one, if you want to graph this in your calculator, you actually have to do it twice on 2 separate lines. You have to do negative 3 plus the square root of x plus 5. And then you have to do negative 3 minus the square root of x plus 5. And, oh, let me turn this off. Quit. Thank you. I didn't hit Zoom 6. Zoom 6. So there's the original parabola, which we had graphed before. And then your calculator, like I said, this is the first equation, and this is the second equation. Your calculator looks a little distorted. Remember, even though it's going 10 by 10 by 10 by 10, it's actually, do you see how this line is stretched out more? So that's why it makes it look distorted, just so you know. You can actually make it zoom square if you want to, but there you go. You did the inverse, and you can even put y equals x through it. All right, this one is my favorite one, and I don't know why I get really frustrated, because every year I do this again to calculus. They learn the same thing again in the beginning, and they don't know how to solve for the inverse function. So let's do this one. So let's call this x. Let's call this y. How do you solve? How do you solve for y when it's got one on top and one on bottom? What should I do? Multiply 1 minus 2. If those of you who don't know, this is what I always teach them. You know, you want to make them equal proportions. Sometimes it's easier that way to remember that step. You do want to distribute x into each piece. So this would be xy minus 2x. Y minus 1 times 1 would just be y minus 1. What do you do now? Because again, I got y's on either side.
Add 1.
Okay, but how am I going to solve for y?
You already have
Plus 2x.
Okay, so if you had, let's just think about this. If I had x's on either side, like 2x plus 7 equals 3x plus 5, your teacher told you to do what?
subtract.
You would combine like terms. Brian, you are on the right track. You would combine your like terms onto one side and bring everything else over to the other, correct? Okay, so we are going to bring all our y's on one side and all our x's and numbers to the other side. Bring everything else that doesn't have a y in it to one side. So really, doesn't that mean you just switch these two? Okay, so write this down. xy minus the y over Add the 2x over there would become positive 2x equals 1. And then Brian just said it. Good job, Brian. Factor out a y. That would isolate your y. And now how do you get y by itself? Just divide out that quantity. That right there is the inverse of that function.
Where'd you get x minus?
Where to get x minus 1 from? Factor out a y. Oh, it's not x. Yeah, no, it's x. Factor out a y from here would be x. Y from y is 1. Okay. Easy stuff. All right, so you will have to graph tomorrow. You will have to find the inverse functions. And the last and final 2 things you'll have to do is what's called a horizontal line test and a verify that 2 functions are inverses of each other. So here's the third part. Horizontal line test. Have you heard of the vertical line test?
Yes.
Okay, what does the vertical line test do?
Function.
It tests if the function is a function. That's what it's, you given a f of x and it says, am I a function? That's what the vertical line test. Guy has to go through it one time. The horizontal line test is, write this down. If the horizontal line intersects the graph of f of x once, then it's, in capital letters, inverse is a function. So going back to Mr. Parabola that I had, he is a function. If I do a vertical line test, I pass through it once. But if I did a horizontal line on that, is its inverse a function?
No.
No, it hit twice. And we saw that right here. This inverse right here, that is not a function. It fails the vertical line test. Okay, so now the horizontal actually helps us determine if the inverse is a function. So, for example, f of x equals the absolute value of x minus 1. Is its inverse a function? All you have to do on this tonight for homework, you go to your pretty calculator, okay, and you type in the absolute value of x minus 1, but you actually should know what that looks like. Please tell me what that looks like right now.
Right one.
It is a v. Where does it been shifted to the right? Okay. If you perform, and so you will sketch the graph tonight, y'all. You will sketch it. If you perform the horizontal line test on this function as it is right now, is its inverse a function then? No. The inverse of f of x is not a function. Okay? It's a function, but its inverse is not. Same thing here. I'll give this one to you. I'll actually show you what it looks like. It's that cubic function. It does that little disco graph like that. Is this inverse a function?
Yes.
It does, right? If you draw horizontal line through any point, it passes only once. So its inverse is a function. That's all you have to do tonight. Sketch the graph. Tell me yes. Verify that 2 functions are inverses. So let's write down the rule and then I'll tell you what you have to do. It's actually quite simple. The rule is the following. Okay? All you have to do to verify that 2 functions are inverses of each other is either fog or goff it. It actually doesn't matter, fog it or goff it. And if your output is an x, then they are inverse of each other. Then f and g are inverses. So I'll show you one of your examples on homework tonight, and we are done. So they're going to give you two functions. They're going to say, I've got f of x being 2/3 x plus 2. I've got another function, g of x is 3/2 x minus 2. Prove they are inverses. Prove it to me. Well, they are. Why? Prove, because it is. You have to prove it. There's two ways to prove it. You could switch the x and y, solve for y, and make it match up to that one. I mean, I'm totally okay with that. But really, it's just easier to fog or golf. Okay? So right now, what do you want to do? You want to fog it or you want to golf it? You want to fog? Okay, let's take this. Let's plug this in here. And let's see what we get out. We should get out an x at the end when we simplify. So rewrite this equation right here. 2/3 instead of x, rewrite times 3/2 times x minus 2. That's the x, right? That was my x, the g function, plus 2. And then do a little algebra. What's 2/3 times 3/2? What does that cancel out to be? 1. So I'm left with x minus 2 and a double set of parentheses, but do those parentheses really matter? No. Add 2. What do you get? You just proved they're inverses. Done.
Wait, but what about golf?
It will be the same. Do it. You can fog it or golf it. You'll get the same, as long as you get out x.
So we only need something.